Determine if theta equals 2e to the 3t minus e to the 2t is a solution to the differential equation d squared theta dt squared minus theta times d theta dt plus 3 theta equals negative 2 e to the 2t. So get ready because I'm about to say e and t a lot. Essentially, all we have to do is take two derivatives of our given theta equation and plug all those values into this differential equation. And if the left-hand side and right-hand side equal each other, then we can say that it is indeed a solution. So let's take the derivative theta prime, where we're taking it with respect to t. So if you take a derivative of an exponential term, all you have to do is take the coefficient of the independent variable and multiply that by whatever's in front of the e term. So 3 times 2 is 6 e to the 3t. And doing that again here, we have 2 in front of t, so we bring that in front. 2 times 1 is 2 times the negative value is negative 2 e to the 2t. And doing that one more time, we take theta double prime equals 3 times 6 is 18 e to the 3t minus 4, because 2 times 2 is 4, e to the 2t. Now let's rewrite this equation here. We can call it theta double prime instead of d squared theta dt squared minus theta times theta prime plus 3 theta equals whatever was on the right hand side. Now let's plug in the value. So we can put a bracket for theta double prime. We just take this formula here, 18 e to the 3t minus 4 e to the 2t minus theta 2e to the 3t minus e to the 2t times theta prime 6e to the 3t minus 2e to the 2t plus 3 theta, so 3 times just our theta formula, and that equals negative 2e to the 2t. So you might be tempted to say that the left-hand side automatically doesn't equal the right-hand side because you see an e to the 3t term, and we know that there's only an e to the 2t term. We got to be safe and understand that there's a possibility that the 3t terms might cancel out. So we got to do out this entire left-hand side. Let's just do that really quick. So we got 18 e to the 3t minus 4 e to the 2t. We don't really change much there. And now we have to distribute the variables, and we can keep the negative out. And we have to also be careful that whenever you're multiplying these exponential terms, you just have to add whatever's in the exponent together. 2e to the 3t times 6e to the 3t is 12. E to the 3t plus 3t is 6t. We did the first part, we got to do the second now. 2e to the 3t times negative 2e to the 2t is negative 4. 2 times 2 is 4. E to the 3t plus 2t is 5t. Now doing the inside term, negative e to the 2t times 6e to the 3t is negative 6e to the 5t. And doing that once more, plus, because there's double negative, 2e to the 4t. And now closing the parentheses, plus 6e to the 3t, we're just distributing the 3, minus 3e to the 2t, equals negative 2e to the 2t. So now we see a 6t term. And we can 100% assume that there is nothing else to cancel that. There is no plus 12e to the 6t to get rid of it. Now we can skip the whole step of reduction and automatically assume that left-hand side doesn't equal right-hand side. So, theta is not a solution. If you have any questions on this process, leave in the comments below, and good luck.